In this example, we're going to find quartiles for an even number of data values. Here we have a data set of measurement collected by measuring the lengths in meters of 10 long jump attempts. So the first thing we're going to do is to list the data in order from smallest to largest. So we have 5.1 is our smallest number, and then 6.7, 7.1, 7.9, 8.2, 8.3, then next would be 8.4, 8.8, then 9.0 and 9.2. Now to check to make sure that you've got all the numbers, maybe just count the numbers that you began with, which was 10, and count to see how many you've ordered, which we also have 10 here. So we should be pretty confident that we've got all the numbers. Now what we want to do is to find the range. Remember, the range is just the highest value minus the lowest value. So here our range will be 9.2 minus 5.1, which is simply 4.1. Next we're going to find some quartiles. So to begin, let's find the median, that's quartile 2. Now since we've got an even number, that's going to mean we've got two middle values, 8.2 and 8.3. So that's quartile 2. So our quartile 2 is going to be halfway between those numbers. So it's going to be 8.2 plus 8.3 divided by 2, which is 8.25 meters. Next, we're going to find quartile 1. So looking at our data set, you can see that quartile 1 will be 7.1. So that's our lower quartile, 7.1. And quartile 3 will be 8.8. Now we can find our interquartile range, IQR. IQR is just the difference between Q1 and Q3, so it'll be 8.8 minus 7.1, which is simply 1.7 meters. Okay, lastly, part D, we want to interpret what the IQR is. So the IQR is the range of the middle 50% of the data. So essentially we've cut off the bottom quarter and the top quarter, and we're left with the middle half of the data. So in this case, our interpretation is that the middle 50% of jumps differed by less than 1.7 meters.